This is N. Kalvili, working as an associate professor in KS Rangasamy College of Technology. The subject is electrical energy utilization, conservation, and auditing. Module 2, energy efficiency in thermal utilities. Topic is about a furnace. What is furnace? The furnace is an equipment to melt metals for casting, heating materials, change to shape like a rolling, forging, and change of properties with a heat treatment. And the types and classification of furnaces according based on the method of generating heat, combustion type, and fuels and electric type. Furnace classified into according to the mode of heat transfer, according to the mode of charging and mode of heat transfer. It is so according the first one, according to the mode of heat transfer, it will be open fireplace furnace and heated through liquid medium. And similarly, according to the mode of charging, it is periodical and continuous. So in periodical, the forging, re-rolling, and pot, and these three are comes into the periodical. The continuous is glass tank, melting, regenerative, and so these are all comes under the continuous periodical type. So according to the characteristics of an efficient furnace, the furnace should be designed so that in a given time, as much as material possible can be heated to an uniform temperature as possible with the least possible fuel and labors. So the furnace energy supply in flue gases directly contact with the stock, and the type of fuel chosen is very very important. For example, some stock will not tolerate sulfur in the fuels, but also soil fuels are will be release the particular matter as like dust, so which will interfere with the stock replaced in the inside the furnace. Hence the majority of the furnaces use liquid fuel, gases fuel, or electricity as energy input. So, ferrous steel cast iron or melting furnaces such as induction and the furnaces are using electricity, and non-ferrous melting furnaces using the oils. So these are the difference between the ferrous and non-ferrous cast furnaces. The first one is about the oil fired furnaces. So in this furnace, oil is in the major fuel used in reheating the heat treatment furnaces. So the oil fired furnaces is used in furnace where the pressure of sulfur is undesirable. Similarly, the furnaces operate in as efficiency as low as 7% against up to 90%. So it is achievable in other combustion equipments such as boiler. So this is because of the high temperature at which the furnaces operate to meet the required demand for the material. So for example, the furnace heating the stock by 1200 degrees Celsius, and it will be given to relieving the temperature about 1100 degrees Celsius. So resulting the loss through the stack. And what is the forging furnaces? Forging used for preheating the billets and ignites and attain the forging temperature. So the furnace temperature is maintained from 1200 degrees C to 1250 degrees Celsius. So forging furnaces use an open fireplace system, and most of the heat is transmitted by radiation. So the typical loading in the forging furnace is about 5 to 6 tons, with the furnace operating for 16 to 18 hours of daily. So the total operating cycle can be divided into heat up time, soaking time, and forging time. So re-rolling mill furnaces will be the next type, and it has the batch type furnaces and continuous pulse pusher type. So the batch type furnace is used heating up the scrap, small inerts and billets weighting 2 to 20 kgs for the batch of rolling, one type of rolling. So similarly, the charging and discharging of the material is done manually. So the final product is in the form of rods or and it is strips. Operating temperature, the range is 1200 degrees Celsius. The total cycle time can be categorized into heat up time and uh, cooling time, discharging time. So similarly, the continuous pusher type, the process flow and operating cycles of the continuous pusher type is same as that of the batch furnace. So everything is same, but the material or the stock recovers the part of the heat in fuel gases, and it moves down to the length of the furnace. So here the operating temperature is 1250 degrees Celsius. So heat absorption by the material in the furnace is slow, steady, and induction for the entire material for the for the cross section of the completion with the batch type. Heat transfer in furnaces. So this is the schematic diagram is given for the furnace, and where the burner is given and the flame will be given into the furnace, and the combustion products and the convention radiation uh, uh, that will be taken into radiation from the flame. So the radiation from the flame, hot combustion products, and the furnace walls and the roof. So convection due to the movement of hot gases over to the stock service surfaces. And according to the continuous reheating furnaces, based on the method by which a stock moves through the furnace, stock placed is side by side to form a stream of material which is moved through the furnace. So stocks placed on the hearth of supporting structure with the moves to the stock. And this is the schematic diagram for the furnace, where the performance evaluation for the typical furnace. So it will be entering, the flame will be entering into one place, and the useful output heat or the load and the cooling, that will be at the exhaust. So the flue losses will be at the another side. So the gross fuel input, net fuel input, available heat. So these are all given clearly in this diagram. And the wall loss, stored heat, opening loss, useful output, and the cooling, everything is at the exhaust side. And the various furnace losses, one is a wall loss. So how the wall will be conducted and the loss will be taken place, and the heat will be inside and the outside will be cooling, so outside will be the wall loss. And similarly, the radiation from the openings, so the material handling, cooling media losses, and finally the flue gas, the outside of the flue gases are coming into another one losses. And general fuel economy measures in furnaces, we have to consider the 9 categories. We can see one by one. First one is complete combustion with a minimum excess of air. So the minimum excess of air is very, very important to the amount of heat loss in flue gases depends upon the amount of excess of air. So in the case of furnace carrying away flue gases from 900 degrees Celsius, and the percentage of heat lost is shown in table. So if the excess of air is 25, the percentage of loss total heat in the fuel, it is about 48, and the excess of air 50, and it will be 55. So likewise it will change. And what is the method of correct heat distribution? Here there are the two pictures given, what is the wrong and what is right. So to prevent the flame in pigment and to avoid high flame temperature, that is the wrong method. To avoid the high flame temperature damage of the refractory and for the better automation. So we have to avoid the high flame. Instead of that, we have to low flame at two areas. Similarly, in the same one, heat distribution in the furnaces, alignment of the furnace is very important at properly to avoid touching the material to reduce the scale losses. So the first picture, it will be aligned, the flame will be aligned in the stock, but it will only preferable at 3. But in the second picture, it will be commonly given to all the stocks. The heat will be transferred to all the stocks. The third one is about operating at desired temperature. So the temperature for different furnaces, slab reheating furnaces about 1200 C, and rolling mill furnaces also 1200 degrees C. Bar furnace for here sheet mill, it is 800. Beige type annealing furnaces from 650 degrees C to 750 degrees C. So the correct temperature ensures the good quality products, and the temperature higher than required would only use up more number of fuels. And the next one is reducing heat losses from the furnace openings. Heat loss through opening consists of direct radiation and combustion gas that leaks through the openings. And maintaining the correct amount of furnace draft is very important. Here it will be given how the air is infiltration, and the draft will be gas exfiltration is given. And optimum capacity utilization, there is a particular loading at which the furnace will operate at maximum thermal efficiency. And waste heat recovery from the flue gases is very important for the stock preheating, combustion air preheating, and using the waste heat for the other processes. And minimizing the wall losses, about 30% of the fuel input to the furnace generally goes to make up the heat losses in the intermediate and continuous furnaces. So the emissivity of wall, thermal conductivity, and refractories wall thickness, whether the furnace is operated continuously or intermittently. And the uses of ceramic coatings, the benefit of applying high emissive and ceramic coatings, rapid heat up and increased heat transfer at steady state, improved temperature uniformly, increased refractory furnaces, and elimination of refractory dust. So these are the details about the furnace. Thank you.